The difference between diffusion and osmosis is that diffusion is the movement of a liquid substance from higher to the lower area of concentration, while osmosis is the movement from lower to the higher area of concentration through a membrane. Difference between diffusion and osmosis. Have you ever heard about it? If no, then let's dig in. A membrane is a barrier that may encapsulate the different molecules and allow only selective molecules to pass through it. A membrane can be between two different molecule streams and allows some selective molecules from one stream to pass to another stream. We can also consider the membrane as a wall between two different natural environments. Let us have a bit more detailed look at diffusion for a better understanding of the difference between diffusion and osmosis. Difference between diffusion and osmosis side by side. Diffusion osmosis 1. Movement always works down the concentration gradient. 1. Movement always works up the concentration gradient. 2. It does not require a membrane. 2. Requires membrane. 3. Always particles move from high to low. 3. Always particles move from low to high. 4. Molecules are free to move. 4. Molecules are not free to move, only selective molecules are allowed to move. 5. It can take place in any medium. 5. It only takes place in a medium having a semi-permeable membrane. 6. It can be applied to liquids, solids, and gases. 6. Only applicable to liquids. 7. It is a reversible process. 7. It is an irreversible process. 8. Insist on the system towards stability, equilibrium. 8. Do not insist on the system towards stability, non-equilibrium. 9. Spontaneous process. 9. The spontaneous process, since the solute is independent of the concentration gradient. Let us have a bit more detailed look at osmosis for a better understanding of the difference between diffusion and osmosis. An example of osmosis. Suppose you are fasting for a day and it's too hot weather and you do not have to drink water in order to satisfy your thirst because you are fasting. You go to a freshwater pool and dip your legs inside the water. What will happen? After some time you start feeling that your thirst or your desire to drink water will gradually go down. All this happens because there is a higher concentration of water in the pool than your body, so it starts moving inside your body through pores on your body. As we already know that in osmosis liquid substance moves from its higher to the lower area of concentration. There are dozens of real-life biological examples of osmosis. Soon will be updated. Types of osmosis. There are 3 types of osmosis: hypertonic, isotonic, and hypotonic osmosis. Hypertonic. In hypertonic osmosis, water moves from outside of the cell to inside of the cell because of higher solute concentration in the outer environment. Isotonic. In isotonic osmosis, water moves inside the cell from outside and at the same time exits from the cell to outside, so there is no water movement. Hypotonic. In hypotonic osmosis, water keeps going inside the cell until an equilibrium state is achieved. Let us have a bit more detailed look at diffusion for a better understanding of the difference between diffusion and osmosis. An example of diffusion. Suppose a person, probably your friend, is standing in a corner of a room holding perfume in his/her hand and you at the other corner of the room standing. Your friend, let's suppose, presses the perfume and after some seconds it reaches to you and you experience the pleasant perfume smell. How it reaches you? The answer is simply by diffusion, as we already know that in diffusion particles move from their higher concentration area to the lower concentration area. Simple is that. Types of diffusion. There are mainly 2 types of diffusion: passive diffusion and facilitative diffusion. Passive diffusion, movement of molecules from higher to the lower area of concentration until the concentration gets equal across the medium. Facilitative diffusion, spontaneous movement of molecules across a biological membrane but via transmembrane integral proteins.